So we're going to look at, now that you know what a normal distribution looks like, you also want to know whether or not a data set is normally. If you're dealing with a situation, you're probably told it's a normal distribution or not. But what if you're just dealing with a data set? How do you know if that data set is actually normally distributed? So there's a couple ways we do that. One is we actually look at the density plot. If the density plot looks like a bell-shaped, then it probably is normally distributed. And when I mean bell-shaped, I really mean a bell-shaped, not just that it's symmetric, because you can have lots of data sets that are symmetric that are not bell-shaped. So you want it to be that bell-shaped. And the other thing we look at is something called a normal quantile plot or a normal probability plot. And this plot should look linear. This plot is not something we can do ever by hand. You must use computers to do this. If both these things are true, then most likely you have a normal distribution. So let's take a situation. So let's suppose that the size of a fish is very important to commercial fishing. A study conducted in 2012 collected the lengths of Atlantic cod caught in nets in Kosovo, sorry about that, data. Data based on the information from the study is in the table below. Determine if the data is from population that is normally distributed. So here's our data set. And what we're going to do is we're going to go ahead and put this into R. So I'm going to go ahead and copy this data set and post it into R. So copy the whole thing. And then I'm going to go into the R Studio and I'll clean it up a little bit. And we're going to go ahead and put this into R. So we're going to read this data set in. And now we have that data set in there. And so this is what the data set looks like. It's not real hard to tell from this whole data set what it's going to look like. So we're going to go ahead and do a density plot. So one thing to remember, to do density plots, you need to have Mosaic on. If you're using an RMD file, then the RMD file probably has Mosaic built into it. But if you're not, if you're just using the console, then you need to make sure you go and turn Mosaic on. So go down to find Mosaic. Make sure the checkbox next to it is checked. And so here's Mosaic, and notice the check box is checked. If it wasn't checked, you just check that box and you would have it. And then the first thing we're going to do is we're going to do a density plot. That's a graph, so graph function, then a density. Make sure you get the density one, not the DNS, but density. We need to use the variable that's in ours. I look at the variable, and there happens to be the variable of length. And then we're also going to say where the data set is. It's COD. And then remember, all your graphs should have titles. So this is the length of Atlantic cod. And then we're going to go ahead and say we want to do this graph. So let's go ahead and graph this. And there's the graph. So I'm going to go ahead and first post this into my notes that I have. So you just can copy, just highlight and then copy. You can put this in where your notes are. We're going to do the density plot. So there's our density plot. And then I'm going to go ahead and grab the graph. So I go over here to the plot. I go to export. I say I want to copy to clipboard. I then have to right click to copy it. There it's copied. And I go back into here. And I'm going to go ahead and paste that graph in. And there's my graph. And so looking at this graph, it looks a little skewed right. Looks like this end is a little bit long. So we need to look at some other things, but it looks a little symmetric. Bell-shaped. So it's somewhat bell-shaped. It could be considered slightly skewed right, but we're going to go ahead and say it's bell-shaped. Because we also didn't have a whole lot of data, so we had probably maybe more data, it might look more that way. But it's somewhat bell-shaped, not perfect. So we're going to go ahead and do a normal probability plot or a normal quantile plot. So go back into R, close it out. And it is still a graph, so it's a graph function. And there's the QQ. QQ. And so QQ stands for quantile plot. So normal quantile plot. And then again, you're going to put in the tilde and your variable, and then where the data set is. And then you can put a title on it also. And then again, it's the length of Atlantic cod. Oops. And then hit enter. And there's the graph for that. Again, I'll go ahead and copy this, paste this in my work. And then I'm going to go back into RStudio and I'm going to export this image. Copy this image. And then go back into here and paste the image. And there's my normal quantile plot. And so now that I have the normal quantile plot, I can say what I think this is. Linear means it looks like a line. And for the most part, it looks like there's a line going on here. It looks like there's a couple outliers. If you want to look at outliers, you can do a box plot and see how many outliers are. So we could actually do that if we wanted to. So GF box. And then length. And data equals cod. I won't worry about the title this time because I just wanted to see if there were some outliers. And there are a couple outliers. So the rest of it looks pretty symmetric shaping. Looks like it's okay, but because of those two outliers, it is skewing things a little bit. But I still can probably say that it looks somewhat linear with a couple outliers. So given that the normal quantile plot looks somewhat linear, not perfect, but somewhat, and the density plot looks somewhat bell-shaped, the last thing I'm going to go do is look and see how many data sets I have. I only have 40. So my guess is that if we had a much bigger data set, it probably would look even more like linear, and this would look more like a normal bell-shaped. So I can probably safe to say, it is safe to assume, it is most likely, I should say, safe to say that the distribution of Atlantic cod length is normally distributed. And so this is kind of things you would do, and then you do some other studies that might actually say this one's definitely not linear or this one's definitely not bell-shaped. It's pretty obvious when it's definitely not. It's a little bit more nebulous when it's somewhat and we're not positive. But again, since there are only 40 data sets, it probably is safe to go ahead and assume.